Okay, graphing equations of lines. First, let's talk about families of functions. We're going to be graphing a lot of functions this year, and they all have families. Okay, and we have parents, and then we have the children, so to speak. Okay, in a linear function, this is I think the easiest one to do. The parent function is the line f of x equals x. Okay. Every other line is a variation of this line. It's either higher slope, lower slope, negative slope, whatever. Moved over this way, moved over this way. Every single variation. Okay. So let's graph this first one. And the line y equals x. Okay. We needed 2 points to draw a line. Okay, we can always do a table of values. Okay. We only really need 2 points, but we can always put in more if we want. Okay, here 0, 0, 1, 1, negative 1, negative 1. Nice. Perfect little line. Okay. The y-intercept is 0, the slope is 1. That is the most basic line. Okay. How do we graph from there? Well, this is review. So we're going to graph by using the slope-intercept. Okay, remember y equals mx plus b. M is your slope, b is your y-intercept. We're going to graph and compare these to the parent function. I'm going to graph them on one set of axes, just so I don't have to draw the same set of axes over and over and over again. Okay, starting with A, y equals 3x. What's the slope? What's the slope? Okay, well, the slope of this line is 3. If we think of it as rise over run, it's going to be 3 over 1. Your slope, your intercept is, your y-intercept is going to be the point 0, 0 in this case. There's nothing being added, so that means plus 0. So we start with plotting the y-intercept, and then we use our slope, and we go up 3 and over 1. There's our 2 points. We draw the line. Okay, y equals 3x. If you're going to use one Cartesian coordinate plane for multiple graphs, you should always label them. Okay, next question. Y equals x minus 4. Okay, well here, slope is 1 over 1, and your y-intercept is the point 0, negative 4. Plot the point 0, negative 4. Use your slope, rise over run. There's your 2 points. Draw your line. Okay. Now, this one is y equals x minus 4. Now, compared to the parent graph, well, this one, the slope is much higher than the parent graph. It's 3 times it. This one has got the same slope as our parent, but it's been moved down. It's been shifted down 4 units. Okay, next one. Here's another one we're going to graph using the slope and the y-intercept. This one's got a negative slope. Okay, we're going to start with, let's see, just list it out because it's easier. Slope is negative 4 thirds. Your y-intercept is negative 2, the point 0, negative 2, that is. So plot the y-intercept. Now using your slope, you're going to start at the y-intercept and you're going to go down 4, 1, 2, 3, 4, and over 3, 1, 2, 3. There's our new point. Draw your line. Why didn't I go down 4 and back 3? Well, if I keep the negative with the vertical change, then I don't need to go negative with the horizontal change, because a negative over a negative is actually a positive, and we don't want that. Remember, negative slope, the line's falling. Okay, what if they don't give it to you in slope-intercept form? What if they give you the line in standard form? AX plus BY equals C. This is the standard form of an equation of a line. The easiest thing, I think, to do is to find the X and Y intercepts. Because remember, the Y-intercept is when X equals 0, and the X-intercept is when Y equals 0. Okay? Sometimes you get nice numbers, sometimes not, but that's okay. You can deal with that. Okay? So what we did is I created a table of values. I'm just going to find these 2 points, and I'll show you nice and easy how to do it. If X is 0, oh look, the X term is 0, so that means this thing goes away. We're left with negative 2y equals 12. Divide by negative 2, we can do this in our head, negative 6. If y is 0, oh, the y term goes away, and we're left with 3x equals 12. Divide by 3, and we've got x equals 4. There, found my y-intercepts pretty painlessly. Plot them and draw the line between them. There's the y-intercept. There's your x-intercept. Voila. There is the line. 3x plus negative 2y equals 12. Using the definition of subtraction there. Nice, right? All right. Horizontal and vertical lines. Which one's this? Is this the horizontal or is this the vertical? If you can't remember, think about, okay, it's y equals, so that means it's going to cross the y-axis. So what does that make it? That makes it horizontal. And I'm going to graph these on the same coordinate plane. I got y equals 3. I go to 3 and I put a point, and I know it's got to be horizontal, so I just draw that line. I got x equals negative 2. I go to where x is negative 2, and I know it's vertical, so I just draw it. Okay, if you're using graph paper, it's a little easier to stay on the lines. Okay, but here we go. X equals negative 2. Alright, fun stuff. The value y of a copier that is x years old can be modeled by y equals 4,000 minus 600x. Graph and describe the y-intercept, the x-intercept, and the slope. Use the graph. We're not going to use this graph because my graph is not going to be that very accurate. But if you're using your own graph, it should be pretty good. Alright, so graphing. We'll go up by 500s. Okay, so this would be 1,000, 2,000, 3,000, 4,000. X's is years, so we'll just keep that at 1, 2, 3, 4, 5. So there we go. And I'm skipping space. I'm not labeling every single one just because I like to have things spaced out. I get the scale when I do this way, and you should too. Make your graph paper work for you. Okay, 4,000, that's our y-intercept. Okay, if we plug in one of these numbers, let's say 2, I'm picking 2 just because I think 1's too close. Okay, 4,000 minus 1,200 is 2,800. So there's 3,000, so it's going to be just a little below that, right about there. Okay, draw the line. Okay, where I said before my graph is not very accurate, it's not. It's quite inaccurate. But if we think about it, the y-intercept, let's talk about the y-intercept. Y-intercept is when x equals 0. Think about it in terms of what we're doing here. X is our years old, y is the value of our copier. So when our copier is brand new, its value is $4,000. So the value is $4,000 when the copier is brand new. That's our y-intercept. Now what about our x-intercept? Our x-intercept is when y is 0. Okay, we solve for it. We've got negative 4,000 divided by negative 600. So our x-intercept is going to be approximately 40 divided by 6, which is 6 and 2/3. Okay, so 6 and 2/3 is our x-intercept. Now, x represents our years, so when y is 0, y is our value. So when the value is 0, so when a copier is worth nothing, it'll be 6 and 2/3 years old. Okay, so that's and our slope is our rate of change. It decreases in value by $600 each year. Decreases. Okay, so that's putting everything into context. Alright, what I want you to do at home, hopefully you can see this. Let me just do this. I want you to do 4 through 52, every other even, at home. The rest you can save for in class. And good luck. See you later.